Hola, mi clase. So we are doing 7.3 multiplying special cases. Our essential question is still multiplying polynomials. We're just going to do special kinds. So it's the difference of squares. So it's the product of the sum and difference of the same two values. So why is a plus b squared considered a special case when multiplying polynomials? So let's just apply our regular polynomial situation. I really like the table method, so I'm going to use the table method. If you like the other method, you can of course use that one. So a plus b squared is the same as a plus b times a plus b, right? Two things squared. And that's what they meant by the same value. This is the same value. A plus b and a plus b are the same value. So I'm going to put a and b here. So I'm going to multiply and get a squared. I'm going to multiply and get ab. I'm going to multiply, get a times b. I'm going to multiply and get b squared. So I now have a squared plus ab plus ab plus b squared. But we can actually combine like terms here and here because this is AB and AB. So now I have 2AB. Right, I have two of them. One here, and then I just have plus B squared and plus A squared. So what makes them special is if you notice, you can, when you get A plus B squared like this, you can just square A, the first number, square the second number, and multiply and times them by 2. So you don't have to do all of this. That's what makes them special. Okay, so we're going to practice using this situation on the next couple of problems. So you can see down below we wrote that down for you. So a plus b squared is the same as a squared plus 2ab plus b squared. So here's what it looks like. 5x, I'm just going to go 5x squared. Right, I'm going to square that. I'm going to go plus 2 times the first one times the second one. It is negative. And then I'm going to go plus negative 3 squared. So that's what I did down here. So 5 squared is, oop, that was glitch, 25. And x squared is squared. Well, 2 times 5 is 10. But 10 times negative 3 is negative 30. And then x. And then negative 3 squared is positive 9. And there we go. That is what makes it special, that I don't have to fill in a bunch of things and add. So this one says, what's the product of a plus b and a minus b? So they're not exactly the same thing. One's plus, one's minus. Again, I'm going to use my table method. And like I said, I really like the table method. So I'm going to put a, and I'm going to put negative b right here. So again, I get a squared. Here, I get negative ab, right? Negative times a positive is negative, and a times b is a times b. Here, I get a times b, and here, I have negative b squared. Because b times b is b squared, and times it by a negative is negative. So I have a squared plus ab minus ab, and then minus b squared. So again, I can combine my like terms. But if we notice, they're opposites of each other. I add an AB and I subtract an AB. So guess what? The AB just disappear. These cancel each other out. And what I'm left with is just a squared minus b squared. And that's why when you have the same exact thing added and then subtracted, it's a special case because all you have to do is square A, square B, and subtract them. So let's practice that. So again, A plus B times A minus B is going to be A squared minus B squared. So all I'm going to do is take this, that's A, and I'm going to square it, and I'm going to minus the second number, which is just B, and I'm going to take that number and square it. And so I get 25y squared minus 1. Done. All right, says a graphic designer is developing images for icons. The square pixelated image, that's this one right here, and it's a square, so this and this are the same, is placed inside a border that is 2 pixels wide on all sides. If the area of the border of the image is 176 square pixels, what is the area of the image? Okay, so here's what we're going to do. We know that we have this total area, right? This big piece. Okay, so we have the total area. And we are going to then subtract the image area. And the reason we're going to subtract it out is because that will then give us the border, right? That will equal what they call it, the border, yeah, border area. I ran out of room, so I'm going to write it down here. Okay, right, so the total thing, the whole big thing, minus this little pixel shape will get me just this little red border. Okay, so what we're going to do is we're going to find the area of the big one. So that's x plus 4 squared, because it's a square. See, x plus 4, minus the little guy. The little guy, it's hard to tell, but it's these right here. Okay, so it's just x squared. And we know what that actually equals. It told us right here. The area of the border is 176 square pixels. So we want to know what's the area of the image. So we got to first solve for x. So this is that squared situation where we can just do a squared plus 2 times 4 times x, right? A and b times 2, and then plus my b, which is 4 squared. And then we're going to minus x squared, and that's going to equal 176. So if I do some cleanup, let's just clean this up. I'm going to go x squared plus 8x plus 16, I forgot the 1, minus x squared equals 176. Now I need to combine some like terms. I've got a positive x squared and I've got a negative x squared, so they're going to cancel. And I'm going to be left with 8x plus 16 equals 176. So I'm going to subtract 16. I'm going to get 8x equals, well that's 0, that's 6 and 100. And then I'm going to divide by 8. And we actually get that x is 20. Now that only gives me the side length. It wants to know what is the area. So for the area, we're going to do 20 squared, and that's going to get me 400. And there we go. It's the 400 square pixels. There's your answer. All right, so this would be good practice for you. We're going to simplify this. So this is the difference one. So why don't you try pausing and trying to apply the difference problem and see how it goes. All right, so remember this one, we just take A and we square it, and we minus B after we square it. So I get, oh, I forgot my squared here. So I get 4x squared minus 81y squared. I'm done. That's why the special cases are so nice. So that gets us to this. So it says, how can you use the differences of two squares to find the product of 43 and 37? So what we have to do is we want it to be the same A and the same B, right? That's what we've been dealing with. And it says differences, okay? And we want to know how we can use what we just did, the special cases, to find this without actually really doing much. So here's what we're going to do. We're going to break up 43 into two numbers, and we're going to break up 37 into two numbers. But A and B, those two numbers, have to be the same for both. And what we're going to do is do the difference one like this. So let's think about that. What can I break up 43 to and 37 to so that A is the same and B is the same? Well, hopefully you said, well, 40 plus 3 and 40 minus 3 get me the same A and B. So now we can use our special case to find the product of these without doing something crazy. So I'm going to go 40 squared minus 3 squared, because it's A squared, B squared, subtract them. 4 times 4 is 16, I'm just going to add 2 zeros, minus, this is 9. And so if I subtract 9, I know I need to borrow. It's 5, what is that, 591? Because I'm going to borrow from here, 5, borrow from here, 9, borrow from here. Yeah, there we go, 591. Done. You can check it on a calculator. What's 43 times 37? But it should be 1,591. And that's why how we can use this difference to use it for really big numbers. All right, so the things to remember are just memorize those rules, okay? It's a lot of algebra stuff. Is just memorize the patterns, memorize the rules, memorize the patterns, memorize the rules. Here's your independent practice, and I will see you next time. Adios.